Hello friends, the man who does not read books has no advantage over one who can't read books. So its meaning is that you have to read. If you don't read, you don't have advantage over one who cannot read. That means we have to read. So, I am Senapati from Career Academy. Today's video is just extension of my previous video which was regarding electric field and field intensity. In this video, I am going to explain electric field intensity due to point charge. So, suppose this is the charge Q, point charge, electric field intensity due to point charge. P is a point. At this point, I want to find the electric field intensity due to charge Q. I am joining this one. So, suppose Q naught is the test charge present at the point P. Test charge in the sense it is positive, very small charge which does not affect the field to be measured at this point. In my earlier video also I mentioned about the test charge. Now Q is the source charge. I have to find the field intensity at the point P. At the point P the test charge is Q naught. Now according to Coulomb's law, the electric force F is equal to Q naught upon 4 pi epsilon naught R square. Here I have taken R is the distance between Q and Q naught. This is the unit vector along this line and the direction is outwards. If this is positive, direction will be inward if this is negative. So, this force is the product of Q into Q naught upon 4 pi epsilon naught R square. If I am measuring the field intensity in free space, I have written epsilon naught, that is due to permeability in free space. So, what is electric field at that point? So, we know that electric field at that point is the ratio between force to test charge. I can write this is equal to Q upon 4 pi epsilon naught R square. This is the unit vector. R stands for the unit vector along this line Q and Q naught. I said it is outwards if this Q is positive and inward if Q is negative. So, I can say that electric field intensity at the point P due to the charge Q is equal to Q upon 4 pi epsilon naught R square, and this R stands for the unit vector. It represents only direction along this line. Okay, so this is about the electric field intensity due to point charge. Suppose there are set of charges are there. How to find the electric field? If there are set of charges, we can find the electric field at a point. If there are set of charges, we can find the electric field intensity at a point by finding the field due to individual charges and then by adding according to the law of vector addition. Then how? Let us see. Suppose Q1 is a charge, source charge. I want to find and Q2 also charge, Q3 also charge. See here. Qk minus 1 is charge, Qk is charge, Qn is charge. The set of charges are there, Q1, Q2, Q3, Qk minus 1, Qk up to Qn. Set of charges are there. I want to find the electric field intensity at this point P. Electric field intensity at this point. Suppose this R1 stands for the position vector, R2, this is R3, this is Rk minus 1, Rk, Rn. It represents the position vector. Then in this case, how to find the electric field intensity? I can find the electric field intensity by calculating the individual field intensities. E2 up to En. Due to charge E1 for due to charge Q1, E2 due to charge Q2, similarly En due to charge Qn. So the total electric field intensity at the point P, electric field intensity at the point P is equal to E1 plus E2 plus E3 R2 plus En. I can write that this is equal to Q1 upon 4 pi epsilon naught R1 square. This is the R1 unit vector. Similarly, Q2 upon 4 pi epsilon naught R2 square. This is R2. Like that, I can find Qn upon 4 pi epsilon naught Rn square Rn unit vector. Or I not. Here I can write Q1 upon R1 square plus Q2 upon R2 square plus Qn upon Rn square. Okay, or I can write 1 upon, so I think here not appearing. Okay, so I can write this is equal to 1 upon 4 pi epsilon naught. Here I can write k equal to 1 to n, so qk upon rk square rk. So this is the way I can calculate the electric field intensity at a point P due to set of charges, and its direction depends upon whether this is positive or negative. At the same time, I used the vector addition. I have mentioned if there are set of charges, we can find the electric field intensity at a point by finding the field due to individual charges and then by adding according to the law of vector addition. I think this concept will be more clear if I give one numerical example. Let us see. I am giving an example from S.C. Verma, the famous physicist. See here. If 10 microcoulomb and minus 10 microcoulomb are 2-point charges are placed at A and B at a distance of 10 centimeter, then find the electric field intensity. Electric field intensity at a point which lies on the perpendicular bisector, lies on the perpendicular bisector of AB at a distance of 12 centimeter from its middle. See that how the figure is. If 10 microcoulomb and minus 10 microcoulomb are 2-point charges are placed at A and B at a distance of 10 centimeter between A and B, then we have to calculate the electric field intensity at a point which lies on the perpendicular bisector of the line joining A and B at a distance of 12 centimeter from its middle. So first we draw the figure. See, suppose this is A, this is B. This is 10 microcoulomb minus 10 microcoulomb. Now, see here. So A is 10 microcoulomb, B is 10 microcoulomb, minus 10 microcoulomb. This distance is given 10 centimeter. Here to here it is 12 centimeter. Okay. Now we have to find out the electric field at the point P, which is distance of 12 centimeter from the middle of AB. That means its direction like this. This is minus, so its direction will be like this. Now, let us calculate the field at the point P due to charge. Suppose this is electric field at the point P due to the charge 10 microcoulomb. So, I can write here electric field at P due to 10 microcoulomb. That means I can write this is equal to formula. What is the formula? Q upon 4 pi epsilon naught r square r vector. But A to P, I have to find first distance. See here. The distance AP is equal to, here to here is 5. This is the midpoint. So directly I am writing 5 square plus 12 square, which is equal to 25 plus 144. That means this is 169, means 13 centimeter. So I got this one is the 13 centimeter. So the distance AP is equal to 13 centimeter. This is also equal to BP. So I can calculate that electric field at the point P due to charge at A is equal to Q upon 4 pi epsilon naught r square r unit vector I have written. So here I can write the charge is 10 microcoulomb divided by 4 pi epsilon naught r square. In place of r, I am going to write this is 13 centimeter square, or I can write this is equal to 10 into 10 to the power minus 6 coulomb into 1 upon 4 pi epsilon naught. We know this is 9 into 10 to the power 9 divided by 13 centimeter square. So I can write 13 into 10 to the power minus 2 meter square. This is equal to 10 into 10 to the power minus 6 into 9 into 10 to the power 9 divided by 169 into 10 to the power minus 4. If I simplify, I shall get this is equal to 5.3 into 10 to the power 6 Newton per coulomb. So this is the electric field at the point P due to charge at A. Similarly, I can say that this electric field due to charge B is also equal to 5.3 into 10 to the power 6 Newton per Coulomb, because this is 10 microcoulomb, this is also 10 microcoulomb, minus, it does not matter, we will take only the magnitude. But since it is the positive charge, its direction along AP like this, and it is negative charge, its direction like this PB, because this is negative charge, so it will lead. Its direction will be like this, its direction will be like that. But I have to calculate the net electric field at this point P. Now you see that this is 10, this is 10. Suppose this angle is theta, this is also theta. Now you see that now the field is acting like this. So definitely the resultant field will be on the bisector of these two. That means this is theta, this is also theta. So I can say that the resultant field is due to EA cos theta and EB cos theta. So the resultant field at the point P is equal to EA cos theta plus EB cos theta. But this E and EB field at point P due to charge A and charge B both are equal. So I can take the common. So I can write that this is 2 into 5.3 into 10 to the power 6. 5.2 into cos theta. That means B by H. So in place of cos theta, I can take 5 by 13. If I simplify, we will get 4.1 into 10 to the power minus 6 Newton per Coulomb. So this is the way I can calculate the electric field at the point P. From this figure, it is clear that the direction of the electric field at the point P is parallel to the AB. From the figure, it is clear. Direction of electric field or net electric field. Net electric field is parallel to AB. Its direction will be like this, it will be parallel to AB. So this is about the electric field intensity due to point charge and also due to set of point charges. So until the next video, bye.